This video is sponsored by Delta Tau. Hi, I'm Miles Budimir with Design World Magazine, here with another installment of our ongoing Motion Control Basics series. And this time we're here to talk about motion controllers. Motion controllers are the brains of any motion control system. In feedback-based systems, they take an input command from the user, compare it with the feedback signal from the motor, and take some type of corrective action to bring the output and input in line with one another, ideally with little or no error. A motion controller also creates the trajectories that the motor follows in order to meet the desired commands. Also called motion profiles, a profile is basically a sequence of position commands versus time. This tells the motor where to position the load and how fast it must do so. The motion controller uses the trajectories it creates to generate the proper torque commands. These torque commands are then sent to the drive, which powers the motor and creates motion. Because of the large amount of signal processing required for these actions, motion controllers typically use digital signal processors, or DSPs, for this task. DSPs are specifically designed to perform mathematical operations quickly and can handle the algorithmic processing better than standard microcontrollers, which aren't designed to handle large amounts of mathematical processing. There are a number of common motion profiles, including trapezoidal, ramp, triangular, and complex polynomial profiles. Each of them is used in certain conditions and situations where that type of motion is called for. For instance, a trapezoidal profile is characterized by constant velocity and acceleration, and a graph of the velocity versus time profile is in the shape of a trapezoid. Motion controllers also use some of the basic control laws to implement motion. The simplest of these is called proportional control, which represents a constant integer gain. This is the simplest type of control to implement. From proportional controllers, one can add either a derivative gain or an integral gain. The combination of these three, known as PID, represents one of the most common and powerful types of control algorithms. Now, practically speaking, motion controllers come in a variety of sizes and types. In general, motion controllers fall into one of three categories: standalone, PC-based, and individual microcontrollers. Standalone controllers are entire systems typically mounted in one physical enclosure that includes all of the necessary electronics, power supply, and external connections. These types of controllers can be built into a machine and are dedicated to one motion control application that could involve controlling a single axis of motion or multiple axes. PC-based controllers are mounted onto the motherboard of a basic PC or a industrial PC. These types of controllers are mainly processing boards that may generate and execute motion profiles. The advantage of PC-based controllers is that they provide a ready-made graphical user interface that makes programming and tuning the control much easier. And lastly, there are individual microcontrollers. These are individual ICs that are often designed into a printed circuit board, along with feedback inputs and outputs to drivers that control a motor. While these controllers are relatively inexpensive and have the advantage of giving designers chip-level access to their systems, the main drawback is that they require good programming skills to configure and implement.